Good morning, guys. This is the 2.3 part 2 video. We talked last week about the remainder theorem and factor theorems. When you evaluate a polynomial using synthetic division and your remainder is 0, then you have shown that whatever the factor is, or I'm sorry, whatever the parenthesis is a factor. So like if x minus 2 goes into something evenly, your remainder would be 0. So if you're going to show that x minus 2 and x plus 3 are factors, they're telling you that they are factors. You just have to prove it. So what we're going to do is I'm going to first evaluate using synthetic division, and I'm going to use x minus 2. So set x minus 2 equal to 0. So I use positive 2. I write out my coefficients of my exponents. So 2, 7, negative 4, negative 27, and negative 18, and then we use our synthetic division. So bring down our 2. 2 times 2 is 4, and 7 plus 4 is 11. 11 times 2 is 22. Negative 4 and 22 is 18. 18 times 2 is 36. Negative 27 and 36 is 9. 9 times 2 is 18, and negative 18, positive 18 is 0. So while evaluating, if I get a remainder of 0, that proves that x minus 2 is a factor. We'll do the same thing with x plus 3. So I'm going to set x plus 3 equal to 0. So I'm going to say, okay, negative 3 goes in my box. I'm going to evaluate. 2, 7, negative 4, negative 27, negative 18. So bring down my 2. 2 times negative 3 is negative 6. 7 and negative 6 is 1. 1 times negative 3 is negative 3. Negative 4, negative 3 is negative 7. Negative 7, negative 3 is positive 21. Negative 27 and 21 is going to give me 6. Negative 6. Negative 6 and negative 3 is going to give me positive 18. And again, my remainder is 0. So since my remainder is 0, I just proved that x plus 3 is a factor of this polynomial. This slide's just saying the same thing. If the remainder is 0 at the given value, then you're proving that the binomial is a factor, and it's also an x-intercept of the graph. So that's where the graph would cross the x-axis. Next thing we're going to talk about is the rational zero test, and this is P over Q. You guys will hear about that a lot. P and Q are just they're numbers in our polynomial, where P is our constant term. P is the constant term, so it's going to be at the end. And our Q is our leading coefficient. For our intents and purposes, we're only going to do P over Q when your leading coefficient is 1. In other classes and other math classes and stuff like that, you guys will see where the leading coefficient is greater than 1, and it just makes the problem a little longer. But for what we're going to do, our leading coefficient is always going to be 1. So the rational zeros test is you take the factors of the constant term and divide it by the factors of the leading coefficient. Like I said, for our class and our purposes, this is always going to be 1. So we're always just going to be using factors of the constant. So if you have a question that says find the rational zeros, okay, well, the first thing you guys should try and do is factor. And if something factors, okay, perfect. So I look at this first equation, x cubed plus x squared plus 11x minus 20. There's no GCF, so then we can try and group it. So if I group this and I take out x squared from my first parenthesis and I'm left with x plus 8, there's nothing that I can take out of 11x and negative 20 that is going to give me, first of all, anything in common, but going to give me a parenthesis that looks the same. So when something doesn't factor pretty or what have you, you have to use the rational zeros test, P over Q. So you're going to take your constant. So I have 20, right? And you're going to list all the factors of 20. So I have 1, 2, 4, 5, 10, and 20. And it can be any combination of those numbers, positive or negative. So we're going to put a plus minus in front of those numbers. And now we're just going to use synthetic division to see which one of these factors or which one of these numbers is a factor, which goes into it evenly. And then you can factor your resulting polynomial from there. So I'm just going to start with 1, positive 1. If it works, great. If it doesn't, we go to negative 1. So let's write out our coefficients. I have 1, 8, 11, negative 20. So when I do my synthetic division, I bring down 1. 1 times 1 is 1. 8 plus 1 is 9. 9 times 1 is 9. 11 and 9 gives me 20. 20 times 1 is 20, so 0. So I just proved right here that x equals 1 is a factor, or is a 0 of this polynomial. And now I write my resulting polynomial, so I have x squared plus 9x plus 20 equals 0. And I can factor this, because I know that x plus 5 and x plus 4 will multiply to give me 20, but add to give me 9. So I know my other zeros of this function are negative 5 and negative 4. Right here, all three of these. All right, we're going to do the same thing here. No GCF, grouping's not going to work, so I'm going to take all the factors of my constant. So plus minus 1, 2, 3, and 6. And I'm just going to evaluate using synthetic division until I get a remainder of 0. So I'm going to try positive 1. So I have 1, 2, negative 5, negative 6. Bring down my 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 5 and 3 is negative 2. Negative 2 and 1 is negative 2, so I get negative 8. All right, positive 1 is not a factor of this polynomial, so try negative 1. 1, 2, negative 5, negative 6. 1 times negative 1 is negative 1. 2 and negative 1 gives me 1. 1 times negative 1 is negative 1. Negative 5 and negative 1 is negative 6. Negative 6 and negative 1 is positive 6, so 0. So you just proved, or I just proved, we just proved together that x equals negative 1 is a 0 of this polynomial. And now I can write my resulting polynomial. So I have x squared plus x minus 6 equals 0. And now we see if this factors. And 90% of the time it will. You don't have to do synthetic division again, which is fantastic. So my factors of 6 that add to give me a positive 1, but multiply to give me negative 6, that's going to be x plus 3 and x minus 2. So my other zeros are at x equals negative 3 and at x equals positive 2. All right, same thing. I have a big polynomial here. X to the 4th is my highest exponent, so I know I'm going to have 4 zeros. So I'm going to take my constant and write out all the factors of 12. So plus minus 1, 2, 3, 4, 6, and 12. I always start with positive 1, then go to negative 1, then go to 2. You guys can do what you'd like. If you'd like to start in the middle and kind of work your way from there, that's fine as well. But I just always start with positive 1. So I have 1, negative 4, negative 13, 4, and 12. So bring down my 1. 1 times 1 is 1. Negative 4 and 1 is negative 3. Negative 3 times 1 is negative 3. Negative 13, negative 3 is negative 16. Negative 16 and 1 is negative 16. 4 and negative 16 gives me negative 12. Negative 12 times 1 is negative 12. 12 and negative 12 is 0. So we just proved that x equals 1 is a factor. So now I'm going to write my resulting polynomial. So x cubed minus 3x squared minus 16x minus 12 equals 0. You can help mommy? Okay, you can sit right here. So GCF, no. Let's see if it factors. Let's see if we can group. So I'm going to group the first two and the second two. So here I can take out x squared. X minus 3 is in parentheses. I'm going to take out negative 4, and that leaves me with 4x plus 3. Does this factor nice and pretty? Can I group this and it works out nicely? No. So that means I'm going to have to use my synthetic division again. So my resulting polynomial was x cubed minus 3x squared minus 16x minus 12 equals 0. So again, 12 is my constant. So plus minus 1, 2, 3, 4, 6, and 12. So I'll try positive 1. 1, negative 3, negative 16, negative 12. Bring down my 1. 1 times 1 is 1. Negative 3 and 1 is negative 2. Negative 2 times 1 is negative 2. Negative 16, negative 2 gives me negative 18. That's not going to work. All right, so let's try negative 1. So I have 1, negative 3, negative 16, negative 12. Bring down my 1. 1 times negative 1 is negative 1. Negative 3 and negative 1 is negative 4. Negative 4 times negative 1 is positive 4. Negative 16 and 4 is negative 12. Negative 12 and negative 1 is positive 12. I have a remainder of 0. So here we just proved that x equals negative 1 is a factor. I have my resulting polynomial as x squared minus 4x minus 12 equals 0. And this will factor nicely. Factors of negative 12 that multiply to give me negative 12 and add to give me negative 4 would be x minus 6 and x plus 2. So my other two zeros are at x equals positive 6 and at x equals negative 2. And then here, again, find all the rational zeros. Well, we say, okay, can I factor this? Is this a quadratic that I can just break into two binomials? No. Can I factor? Can I group? Can I? No. So we're going to say, all right, all the factors of 1. Well, that's easy. Plus minus 1. So let's try positive 1. So I have the coefficient of x cubed is 1. Coefficient of x squared would be 0 because there is not 1. Coefficient of x is 1, and my constant is 1. So I bring down my 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 1 plus... So positive 1 is not a factor. Now I'm going to try negative 1. 1, 0, 1, 1. Bring down my 1. 1 times negative 1 is negative 1. 0, negative 1 is negative 1. Negative 1 is positive 1. 1 plus 1 is 2. 2 times negative 1 is negative 2. This is not a factor. So in this case, guys, there are no rational zeros. If you have any zeros, they're going to be imaginary. So you would say no real zeros for something like this.